All right, so we are going to talk today. We started by talking about organizing, displaying data in the last class. We're going to talk today about how to create a histogram and a frequency table. But that all kind of starts with something called a stem and leaf plot. Have you guys ever heard of stem and leaf plot before? Okay, all a stem and leaf plot is just a way to organize a list of numbers. So a stem and leaf plot breaks things into stems and leaves, where stems are typically like the beginning of the number. So let's say it's the, you've got a list of numbers like this. These are all how many digit numbers? Two. So the stem would be the first digit in the tens column, and the leaves would be all the things that fall into those stems. So for instance, this list, what's our biggest number? If I'm just looking at this, 34. The biggest number I see, the max is 34. And what's the smallest number? 9. So that means I go all the way from a one-digit number 9 up to 34. So when I'm creating my stem and leaf plot, here's my stems, and here are my leaves. All right, I'm going to have 4 stems. The first one is actually 0, 1, 2, and 3. And essentially, those stems are just any number with nothing in the tens digit, all the numbers with 1 in the tens digit, all the numbers with 2 in the tens digit, and then all the numbers with 3 in the tens digit. So, to do that, we go through, and how many numbers in here have just one digit? How many are just one digit? Just 9. So I'm going to put this in my leaf right here at 9, and then that's it. So that just represents how many numbers? 1. It's just one number. 0, 9 is just one number. Okay? Now, what goes in this row?
8.
All the stuff that has what?
1 in the beginning.
1 in the beginning. Which
14,
is what?
14, 12, 18.
And that's it, right? Do I put it in any type of order?
Least to greatest.
Yes, least to greatest. And so my least number is what?
12.
So how do I write that here in my leaf? Just 2. And then what goes next? 4. 8. How many times? Twice. So how many numbers does this represent? 4. Even though there's 5 in the row, what does that 1 represent?
Like the 10.
Yeah, the 1 goes with all of them, right? So the 1 goes with all of them. All right, what about my 2s?
24, 25, 23, 24, 28, 24, 27.
Okay, so that's probably going to be my biggest. And which one is the smallest of those? 23. So I'm going to cross off as I go so I don't forget any. So 23, which means I just put a 3. All right, what comes next?
24.
How many 24s do I have? So I need 3 4s. Okay, and then what? I have 125. 27, and then
28.
So 7, 8. So how many numbers are there in the 20s?
8. 1, 2, 3, 4, 5, 6, 7.
7. There are 7 numbers in the 20s there. There are 7 of them. Okay, and then last but not least, what goes in my 30s row?
32,
34. 34. Good. Okay. Now, again, the whole point of a stem and leaf plot is it's just a way of organizing our numbers. And we're organizing them in groups so that we have basically the units, the tens place on the left side in our stem. And then on the right side, it's our leaves place. And so the stem, think of the stuff they have in common. And then leaves are what branches off of the stem. So on this particular stem of 2, these are all the leaves that we have. So that's our most crowded stem. Okay, now this stem and leaf plot is a 2-digit one. What if they were 3-digit numbers? What would you do?
The first number there.
Yeah, your stem might be 2 numbers instead of 1 number. Okay, if they were all like in the same tens, then it might not be. But your stem might be 2 numbers instead of 1. Okay. All right. We also have back-to-back stem and leaf plots. And a stem and leaf plot that's back-to-back means our stems are in the middle and our leaves go one way for one of in this particular one, this is Marty and Bill's scores for 10 games of bowling. So we'll have Marty on one side and Bill on the other. So our stem and leaf plot, instead of looking like a T chart, is going to look like this. here's our stem, and here are our leaves. And these are for, let's put Marty over here. And let's put Bill over here. Okay, so our scores here range from what? From Marty, let's say what's our minimum between Marty and Bill? The lowest that it gets all together, the lowest number I see, I think is 121 is the smallest I see. Okay, what's the biggest?
168.
168? Anything bigger than 168?
No.
Nope? Okay, so what are my stems then?
No. 2
1,
and
2,
6.
1,
1, 2, 1, 3,
3, 1, 4,
1, 4,
1, 5.
1, 5, and 1, 6. So instead of saying 1, 2, I would say 12. So my stem is 12, 13, 14, 15, and 16. Because this represents all the numbers in the 120s. This is the 130s, 140s, 150s, 160s. So now let's just do Marty. Let's start with Marty. So Marty has how many in the 120s?
2.
2? What are they?
3.
Okay, here's 1, 2,
3.
3. Okay, so what's my lowest? 121. Then what? 123 and 127. All right. This one is a little bit tougher to read. Why? Yeah, you're kind of going backwards. So just keep in mind for Bill, we're going to read it normally. For Marty, we're kind of reading right to left. Okay? What about 130s?
137, 134. That's it.
That's it, right? So which one comes first?
34.
And then
7.
137. Good. Okay, what about 140s?
149, 143, 140, 133, 143. 9.
And then 9.
Okay. What about the 150s?
There's 9.
There's nothing. So Marty's row here is just
Blank.
empty. All right, and then what about the 160s?
167, 168, 162.
Okay, so what's the lowest?
2.
7.
7, and then 8. Good. All right, so there's Marty. So right now, right away, we can tell that Marty has how many high scores? He's got 3 pretty high scores, right? So he's got 3 pretty high scores. If we keep in mind that 168 is the highest, then we already know Marty definitely has at least the highest score. Okay, Bill might also tie him, but that's what Marty is. Okay, so how do we do Bill then?
120 first, 129, 124, and then 128.
Okay, so what numbers do I actually write?
4, 8, and 9.
4, 8, and 9. Okay, 4, 8, and 9.
38, 139. That's it.
130.
130 goes
All right, so what do I put here?
0.
0,
8, 9.
8, and 9. Okay, and now what?
141, 149, 145, 141,
1, 5, and 9.
All right,
150s, there's no one.
so no 150s again, and then
160 only.
just 0. Okay, so, all right, a couple things. First of all, what was I doing as I made my list?
Cross them out.
I didn't even cross these out. For this one, what did I do?
Kind of put different shapes.
I put different shapes and patterns. Why?
To help you keep track.
Identify.
Yeah, so you know which stuff groups together, right? All the ones with dots underneath it. You can do whatever you want. If crossing it out works for you, that's fine. The only reason I don't like crossing out is because then I can't go back and look at it. I can do it pretty easily here, right? Because I can just erase it. But if you are a person who works in pen, which a lot of you guys do, then all of a sudden you're like, wait a minute, I don't know if I'm right. Did I miss a 122? So it's a little hard to tell if you just cross them out, which is why I tend to like doing them in some type of pattern. You can also, if you want to do it, put them all in order and then just do it that way. That just is like an extra step that takes a little more time, but it's up to you. Okay? So now, what does this stem and leaf plot tell me? If I asked you based on this, who's the better bowler, what would you say?
Marty.
You would say Marty's maybe a little bit better, yeah? Are they really different or are they pretty similar? They're pretty similar. Both of them have roughly the same number of scores kind of scattered throughout. The only difference is that Marty did a little bit better twice, right? So a stem and leaf plot is going to allow you to sort of assess what they're doing. Now, why is this a double stem and leaf plot? Because it's got Marty and Bill. What's the harder part about Marty?
It's backwards.
We gotta go backwards. Okay? Do we have to put 15.
No.
No. Well, yes, so it could
Yes,
say the
we
place.
do. Why?
So it could say the
Yeah,
place.
it's a placeholder. It's just like a 0. Do you need a 0 and a number?
No.
Yeah, most of the time you do. If it's 205, if you don't put the 0, then it's 25, right? So if you owe me $205 and you pay me 25 and just say, oh, let's forget about that 0 in the middle, no, I'm not going to forget about that 0, okay? So you need things as placeholders, even though this is empty. And you could answer a question based on this and say, like, which stem did not have any scores in it? And you would tell me 50. Okay? Why were these stems 2 digits and the other ones were 1? These are in the hundreds. Good. So if we're in the thousands, how many
3
digits?
digits.
You won't have to. Okay? Stems, pretty much stem and leaf plots are usually in the tens. Okay? They won't usually even go into the hundreds, but they might for this. Okay? Alright, so all this is leading to practicing making stem and leaf plots. I would like you guys to do I want you to do all 4 of these questions. Okay, so I want you to do all 4 of them. However, I understand it can be a little bit hard because you don't have the actual list on the boards. So if you would like to do them at your seats, that's fine. But at your boards, answer 2, 3, and 4. Does that make sense? Like if you want to make the stem and leaf plot at your seats, that's okay because then you can cross off on the paper. But at your boards, put the answers to 2, 3, and 4. Okay?
Oh, yeah.
Okay, all right, good. You're also, okay, so stem and leaf plots are ways of organizing the data in groups that are grouped by, like in this case, they were grouped by what? Ages. So they're ways of grouping our data in intervals. And interval, again, we talked about this I think a little bit last class. Interval means a set, basically. So the stem 1, essentially, you guys had, stem 1 was pretty long, right? So stem 1 ended up having most of the people in it. So you had stem 1, stem 2, stem 3, stem 4. Basically, those intervals represent how many years? How many years does step 1 really represent?
What?
Not just
Like
1
the
year.
teens.
All your teen years, right? Which would be what? And a little bit outside of that, right? Because what's the youngest?
13 to 12.
From 11. I mean, there's only 12 here, but what interval does it really represent?
13.
Anyone who falls in it from 11 all the way up to 19. So that interval is 11 to 19. Now I understand that there's 12-year-olds in here and there's not 11-year-olds, but they would still, if they were on this list, where would they fall?
Kids.
Into that stem, right? They would go in that stem. So that stem represents everything from 11 to 19. So that's our interval, because that's the group the setter represents. Gabe.
What's the year?
What? Oh, I'm sorry, 10, yeah. So 10 all the way up to 19. So it would represent anyone basically with a number 1 right in front. Okay? All right, yes.
What if that teens were when it starts like 13?
Right, okay, so we're generalizing calling them teens,
Oh.
right? But bring basically anybody with a 1 in front, okay? Whereas the 2s represent who? Everyone from 20 to 29. And in this case, that only was actually, was it 3 people? Yeah, I think 3 people on this list actually. And then the 3s represented what? 30, so all the way from 30 to 39, and the 4s represented 40 up to 49. So interval is a set of numbers that are represented by however many people are in it. Okay, and we use those when we make frequency tables and when we make histograms. And a frequency table is basically taking all the stuff we just talked about and using those intervals to put it into a table. So again, a frequency table, a table is going to look like this, just like when we did the coordinate points with functions. Our function tables look like this, where you've got stuff on the left column and stuff in the right column. So to do this, you start by identifying the least and the greatest values. So in this data, this is the final scores for every golfer in a tournament that are given below. So what are the least and greatest values here? 68 is the smallest.
82.
Okay, and 82 is the biggest. So I want to divide that data into equal intervals, which means do I need to worry about the 10s, the 20s, 30s, the 40s, and the 50s? No. So what intervals do I need to worry about? 60s, 70s, 80s, and I don't need to worry about the 90s. Why? Because no one scored in the 90s. So my intervals would be 60 to 69, then what?
70 to 79. 80 to
And do I need that?
No.
Nope, so that's it, right? So my frequency table is only gonna have how many rows?
3.
3 rows. Now, for a frequency table, you don't need to actually list the data. You just need to tell me how many people are in that section, okay? So how many people scored from 60 to 69?
1.
1.
1.
All right. How many people scored from 70 to 79? All right. Let's document.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15,
14.
14.
All right. So 14 people scored in the 70s, and then how many people scored in the 80s? 1.
1.
All right. So this frequency table is done. That's it. Sometimes you'll see it with tallies. So you can do it with tallies too, where this would look like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. These would look the same because one just looks like a tally.
Yeah.
All right, so you can do it either way. If you'd rather do tallies, like as you go through the list, if you'd rather make tally marks, that's fine. Or if you'd rather count. So this is a frequency table, okay? And this frequency table shows us what? What does that data show us?
How frequent?
How frequent those scores were, that interval was, right? Could we change this by changing the intervals?
Yeah.
Yes? Instead of doing intervals of 10, could we make our intervals smaller? Why would we maybe want to do that? David, what do you think?
Be more precise.
Be more precise. So I'm going to erase what we just did. It never works. Every time. All right, so I'm going to erase what we did. And instead of counting by tens, what else can we count by?
5.
We could count by twos. Twos would be a lot specific, right? So 5s. So let's count by 5s and see what happens. So if we're counting by 5s, do we need 60 to 65? No, why not?
58.
No one was in that. So we're going to start at 65 to what? 70? And then what?
75, 80.
Well, no, 75 to 80 would skip some.
72, 8.
72. What comes after 70?
71.
So 71 to
74.
75. Then what?
76.
76 through
80.
80. And then
81 through 85.
85. Okay, now our data is going to change. How many people scored from 65 to 70 though? 1, 2, 3. So that's it, right? So 1, 2, 3. All right, how many people scored from 71 to 75?
1, 2, 3,
1,
4, 5, 6, 7, 8, 9.
4, 5, 6, 7, 8.
8.
I counted 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, how many people scored from 76 to 80?
1, 2,
3, 4. Wait, 3.
3. And how many people scored from 81 to 85?
1, 2, 1.
Just 1, right? All right. So, which frequency table is better?
The first
First
one.
Hey,
Why is the first one better in your minds?
because you don't
You have to be quicker.
It's less work, okay, but does it tell you as much?
Yes. No.
No, because you see that there's like this big lump of people, whereas when you look at this, you see most people scored where?
70.
Between 71 and 75. On the old chart, all you knew was most people scored between 70 and 79, which is a pretty wide range, right? There's a lot of different scores in there. So when you're planning your interval, you have options, but typically you don't want to do an interval of like 2, because then that's just too many intervals. It's not really allowing you to see any spread of data. But when you're looking at a frequency table, I usually try to do like 5, unless they're huge numbers, and then you do them a little bigger. Okay? All right. So a histogram is just a frequency table on a graph. All right? So when you do a histogram, it looks very much like a what? Bar graph. The only difference is that the bars do what? They touch, and they represent not one number, but multiple numbers. Okay? So the way they did this is they actually did it in groups of what?
3.
What their intervals were groups of 3. So 70, 68 to 70, 68, 69, 70, 71, 72, 73. All right, could we make a histogram with our data too?
Yes.
Yes. Would it look exactly the same? No. Does it make it wrong? No. Okay? It's not wrong, it's just some intervals make a little more sense.